Have you ever pondered how the universe transitioned from a scorching hot ball of fire to the cool cosmos we observe today? This is not just a question of curiosity, but a key to understanding the history and evolution of the universe as we know it. In the beginning, the universe was a hot, dense, and uniform entity. It was a state of extreme heat and pressure where the basic building blocks of matter were in a plasma of quarks and gluons. This state, known as the quark-gluon plasma, is similar to a standard plasma, but at a nuclear level. A fascinating fact is that this state occurred naturally in the early universe, a testament to the extreme conditions that prevailed during that time. As the universe began to expand, it started to cool down, paving the way for the formation of protons, neutrons, and eventually atoms. But this transition from a hot, dense state to a cooler one was not a simple, smooth process. This is where the concept of phase transitions comes into the picture. Phase transitions are changes in the state of matter, like when water turns into ice or steam. But in the context of the universe, these transitions played a crucial role in shaping the cosmos as we see it today. The universe went through a series of phase transitions, each marking a significant change in its evolution. One of these transitions was the transition from the quark-gluon plasma state to a state where protons and neutrons could form. This was the first meaningful transition in the early universe, but many more transitions followed. Each transition was a step away from the high-energy, hot, dense state of the early universe towards a cooler, lower-energy state. In essence, the universe that we observe today, with its galaxies, stars, and planets, has evolved from a hot, dense, and more uniform past. The phase transitions that occurred along the way have shaped the universe, leading to the formation of matter and other forms of energy. So the next time you look up at the night sky, remember that the calm, cool cosmos you see has a fiery, hot past. The universe, as vast and complex as it is, started as a hot, dense entity and cooled down over billions of years, undergoing numerous phase transitions along the way. This fiery past laid the groundwork for the universe's cooling journey. As we delve deeper into the universe's past, we find ourselves amidst the first significant transition. Picture this. An infant universe, a place of unimaginable energy and density, and then, suddenly, a change, the hot Big Bang. This was not an explosion, as the name might suggest, but rather an expansion and unfurling of space itself, a shift from a universe that was incredibly dense and hot to one that was less so. This was the universe's first phase transition, a cosmic metamorphosis of epic proportions. But what exactly happened during this transition? Well, the energy that filled the universe began converting into matter and other forms of energy. It's a little like how water transforms into steam when heated, except on a much grander scale. This conversion wasn't straightforward, though. It was dictated by Einstein's famous equation, E equals mach squared, which tells us that energy and mass, or matter, are interchangeable. During this period, all sorts of elementary particles were born. Quarks, leptons, and their antimatter counterparts. These particles were zipping around, colliding, and transforming back into pure energy. It was a cosmic dance of creation and annihilation. Then, as the universe continued to expand and cool, these particles started to combine to form protons and neutrons. This was the first meaningful transition in the early universe. The hot Big Bang set the stage for everything that followed: the formation of atoms, the birth of stars and galaxies, and eventually, the emergence of planets and life itself. It was the universe's first step from a state of extreme heat to a cooler, more diverse existence. This crucial transition marked the beginning of the universe's cooling process. And as we'll see, this was just the start of a series of dramatic transformations that shaped the universe we know today. As the universe continued to evolve, it encountered another pivotal phase transition. This occurrence is known as cosmic inflation, a second-order phase transition that played a significant role in the universe's cooling. Now, what exactly is a second-order phase transition, you ask? Well, it's when a system smoothly transitions to a lower energy state. Imagine a ball slowly rolling down a hill. That's a pretty solid visualization of a second-order phase transition. So, what's the hill in our cosmic scenario? The hill is the high-energy state of the universe just after the Big Bang. And the ball? It represents the universe itself. During cosmic inflation, the universe, like our imaginary ball, began its slow and steady descent down the hill, transitioning from a state of extreme heat and high energy to a cooler, lower energy state. This is where the term cosmic inflation comes from. As the universe transitioned to this lower energy state, it expanded rapidly, much like a balloon being inflated. This inflation happened at an unimaginably fast rate. In less than the blink of an eye, the universe grew from microscopic to cosmic in size. We're talking a growth factor of at least a factor of 10 to the 26th power. That's a 1 with 26 zeros after it. But what does this cosmic inflation mean for the temperature of the universe? Well, as the universe expanded, the intense heat and energy of the Big Bang got spread out over an increasingly large space. This means that while the total amount of energy remained constant, the energy density, or energy per unit volume, decreased. And since temperature is directly related to energy density, as the energy density of the universe decreased, so did its temperature. So in a nutshell, the second-order phase transition of cosmic inflation caused the universe to inflate rapidly, spreading out the heat from the Big Bang and leading to a significant cooling of the universe. This phase transition further propelled the universe along its cooling trajectory, but the story doesn't end there. Stay tuned as we continue our journey through the universe's temperature timeline, from fiery beginnings to its cool present. Today, billions of years later, we find ourselves in a cooler, more diverse universe. This cooler universe is a testament to the dynamic nature of our cosmos. It's a far cry from the initial hot, dense state that once prevailed. The universe has been on an incredible journey, transitioning from extreme heat to the coolness we experience in the present day. Once a fiery cauldron of energy, the universe has cooled and expanded, allowing for the formation of galaxies, stars, and planets. The phase transitions we talked about earlier played a crucial role in this process. As the universe shifted from higher energy states to lower energy states, it opened the door for matter and other forms of energy to manifest. Interestingly, the universe's temperature isn't uniform. It varies depending on where you are and what you're measuring. Here on Earth, we're experiencing a warming trend due to human-induced climate change, but in the vastness of space, it's a different story. The cosmic microwave background radiation, the afterglow of the Big Bang, gives us a universal baseline temperature of about 2.73 Kelvin. That's just a couple of degrees above absolute zero, the coldest temperature possible. This cool universe has allowed for the existence of life as we know it. Warm-blooded creatures like us humans have evolved to maintain a stable body temperature, giving us a competitive edge in the grand scheme of evolution. The universe's cool present has even enabled us to cultivate our own miniature universes, like portable gardens that harness the sun's energy to foster life. The universe's journey from a hot, dense state to its present coolness isn't just a story of cosmic evolution. It's our story. It's the tale of how an incredibly hot, dense point of energy expanded and cooled to create a universe teeming with galaxies, stars, planets, and life. The universe's journey from a hot, dense state to its cool present is truly a marvel of cosmic evolution. It's a tale of transitions, transformations, and the tenacity of life, and it's a tale that's still being written as the universe continues to evolve. We've journeyed from the universe's fiery past to its cool present, witnessing remarkable phase transitions along the way. Let's take a moment to reflect on what we've learned. Our universe began in a hot, dense, and uniform state, evolving over billions of years into the diverse and complex cosmos we inhabit today. The early universe was a seething cauldron of energy, a temporary state called a quark-gluon plasma. This high-energy state was not meant to last. As the universe expanded, it underwent its first phase transition. Energy transformed into matter and other forms of energy, marking the transition from the hot Big Bang to a cooler universe. This was the universe's first step towards equilibrium, where a physical system reaches its most stable state. The universe didn't stop there, though. It continued to transition smoothly to a lower energy state, a process known as a second-order phase transition. This cosmic inflation set the stage for the birth of galaxies, stars, planets, and eventually life. Understanding these transitions and the concept of equilibrium is crucial for comprehending the evolution of our universe. It's the story of how we transitioned from a hot, dense, and uniform past to the cool, complex cosmos we see today. These transitions, from higher energy states to lower energy states, have been fundamental to the history of the universe. They have shaped the universe as we know it, setting the stage for the emergence of galaxies, stars, planets, and life. And that's what makes studying the universe so fascinating. It's not just about understanding where we've come from, but also about exploring where we're going. It's about uncovering the secrets of the cosmos, one phase transition at a time. Remember to like, comment, and share this video if you enjoyed our cosmic journey. Stay curious and keep exploring the wonders of the universe.